Alright, we're starting 12.5 Day 1 Notes, the square root method. So once we learn how to deal with these square roots or radicals, then we will be able to solve different types of equations other than just quadratics. So first of all, what is a radical expression? It is any expression that contains a radical. Any expression that contains this symbol. So this is a radical. Well, anything inside of that radical, in this case it's just a, everything is inside is called the radicand. And then this number here, n, is called the index. The most common radical we will look at is the square root. It's the one with a 2 there. But actually, when there is no root index given, it is assumed to be a 2 and it's called a square root. So we've seen these before. The square root of 36. We know when there is no number there, it is an implied 2. Okay? But we've also seen things like cube roots when there's a little 3. Or fourth roots are something we will look at. So anything with that little number is the index. Well, finding the square root of a number or expression is the inverse operation of squaring a number or expression. So the square root of 4, we know that is 2 because what times itself gives us 4? 2 times itself. 2 times 2 is 4. The square root of 16. 4 times itself is 16, so the square root of 16 is 4. Well, what about the square root of x squared? The square root and the squared actually undo each other, and that is why they're called inverse operations. So we ask ourselves, what times itself is x squared? Well, x times x is x squared. So that's why the square root of x squared is x. Now look at this note here. A positive number a has 2 distinct square roots, one positive and one negative. So let's look at this for example. The square root of 4 is 2, but what else can the square root of 4 be? We know that positive 2 times positive 2 is 4, but what about negative 2 times negative 2? A negative times a negative is a positive number, so this is actually 4 as well. So the square root of 4 can also equal negative 2. And that's what this note is saying. A positive number under the square root actually has 2 different answers, a positive and a negative answer. Now usually we will just work with the positive answer, but if I want the negative answer, then we'll actually do this and put that negative sign out front. Last note here. A negative number has no real square roots. So let's look at that. The square root of negative 9. Well, we know that what times what is 9? We know that 3 times 3 equals 9. Well, how do I make that a negative 9? I would make one of them negative. But what is the definition of a perfect square? A perfect square is something times itself. So negative 3 times 3 is not something times itself. And that should actually be a negative 9. So this cannot work. There is nothing times itself that can give us negative 9 because we know that positive 3 times positive 3 is positive 9. We know negative 3 times negative 3 is positive 9. So this will not work. And that is why a negative number has no real square roots. Well, let's answer a couple questions. The square root of 49. What times itself is 49? Well, that is 7. Remember this negative sign. If we put a negative out front, that means we want the negative answer of the square root of 81. Well, we know the square root of 81 is 9, and we want that negative answer. So our answer is going to be negative 9. All right, the square root of 100. What times itself is 100? That's 10 times 10. And then negative square root of 1. Well, the square root of 1 is 1. And we just bring around that negative sign. So it's negative 1. We've got a list of these perfect squares here, and I actually want you to memorize these. And the reason we should memorize them is that it will make our calculations so much easier. If you can look at the square root of 81 and say 9, or the square root of 144 and say 12. If you know all of these, it will make solving these radicals much easier. So go ahead and work on memorizing them. All right, 2 more things and then we can start simplifying. First one, a radical expression is in simplest form if 3 things. There are no perfect square factors other than 1 in the radicand. So that means when you look inside that radicand, under the root, if there are any perfect squares left, you've got to get rid of them. And then we'll be finished. Well, second thing, there are no fractions in the radicand, and then there are no radicals in the denominator. Numbers 2 and 3 of this we won't worry about today, just the perfect square factors. Lastly, we need a property that we can use. Well, this is called the product property. And what it says is that the square root of a product equals the product of the square root factors. Well, here's what that means. And I apologize for this message that keeps coming up on my computer. All right, here's what this means. The square root of a times b equals the square root of a times the square root of b. So if I have the square root of a couple of things inside being multiplied, I can split that up and give each of them their own root. And of course, this only works when a is greater than or equal to 0 and b is greater than or equal to 0, because right now we don't know how to take the square root of a negative number. So I'm going to teach you 2 methods to use. You choose whichever one you like, and I will show you how to use both of them for every single example we do. So method 1. This is factoring using perfect squares. Well, that requires you to know those perfect squares that we talked about at the top of the page. So here's how we do this one. To use this method, you must find the largest perfect square that divides evenly into the radicand. So we start by looking at this radicand. We have 24, and we want to know what's the biggest perfect square that can be divided into that. Well, what are our perfect squares? We know we have 1, 4, 9, 16, 25, etc. So now we start with the biggest one and we say, does 25 go into 24? No. Does 16 go into 24? No. Does 9 go into 24? No. What about 4? Yes, it does. Well, 4 times what gives us 24? It is 4 times 6. Well, that property above told us that the square root of 4 times 6 is the same as the square root of 4 times the square root of 6. And then we can keep going. Well, what is the square root of 4? We know that the square root of 4 is 2. So I'm going to cross this out and leave it with a 2. The square root of 4 becomes 2, and we bring that 2 down in front of the root in our answer. Well, what's left inside is the square root of 6. We can do nothing else with that, so we just bring down the square root of 6. And our answer is 2 root 6. Of course, at the end, always check your square root and make sure you got out all of the perfect squares. The next method we'll look at is called factor using a tree. So this one is going to be a little silly, but that's okay, because sometimes silly works for us. So what we're going to do is pretend the radical is a barn and the factors of the numbers are animals. So it kind of looks like a little house. We're going to say this is our barn. Well, inside our barn right now we have 27, and what we actually want to do is find the factors of that. So I'm going to come up here to the side and make a little factor tree for 27. Well, how can I divide up 27? What times what is 27? Well, I know that 3 times 9 is 27. Well, what about 9? 9 can go down to 3 and 3. So now we've gone down to all of our prime factors. We have 3, 3, and 3, and we're actually going to bring all of those being multiplied together under our radical. So I have 3 times 3 times 3. And I got that from my factor tree. Well, here's how we do this barn method. Your factors, or animals, break up into pairs. So we're going to pretend these 3s are all of our little animals in our barn. The animals can only leave the barn if they are in a pair. Well, I see a pair of 3s. So that pair of 3s is allowed to then leave my barn. So once they're paired, they must leave the barn together. So we are taking out one pair of 3s, so I'm just going to bring 1 3 out front. And how does that make sense? I'm bringing out 2 3s, aren't I? Well, what's 3 times 3? 3 times 3 is 9, and the square root of 9 is 3. So we just bring out one of them. Then it says if a factor has no partner, it must stay inside the barn. Well, this little 3 here, that animal is all alone, so it's going to stay inside the barn. And the last thing we'll do is multiply all of the remaining inside numbers and then all of the outside numbers. So what I'll say for this sometimes is outside, outside, and then inside, inside. And that just means we look on the outside, see if there's anything to multiply. Look on the inside, see if there's anything to multiply. That'll make more sense later. Okay? So let's go do some examples and I will show you both methods. So let's simplify. We have the square root of 45. Well, method 1 here. Method 1 is using our perfect squares. So let's write out some of our perfect squares. We know we have 1, 4, 9, 16, 25, 36. 36 does not go into 45. 25 doesn't, 16 doesn't, but 9 does. So we can split this up as the square root of 9 times, well, 9 times what is 45? It's 9 times 5. So now that we got the biggest perfect square, the square root of 9 is 3. So let's cross it out and put a 3. So we will bring down our 3, and then what's left inside the square root is 5. So we have 3 root 5, and that is as simple as we can get it. Well, let's look at the second method. The second method is the tree or the barn method. So we take the square root of 45 and we break it up. Well, what times what can give us 45? We know that 3 and 15 can give us 45. And then 15, we can make that into 3 and 5. So remember, we can take that 3 and the 5 and put them all in our barn. 3 times 3 times 5. Now, if you prefer not to rewrite them in the barn, you can just look at the factors here and look for pairs. Because remember, these animals cannot come out of the barn unless they're in a pair. So what pair of animals do we have? Can we pair 3 and 5? No, those are different animals. We can pair 3 and 3. If you don't want to rewrite them, what I would do is just draw a box or a circle around the animals that you pair. So you can see these are paired, 5 is left over. Well, I have a pair of 3s, so I'm going to bring out that 3. That 5 has no one to go with, so we leave the 5 in the root. So our answer is 3 root 5.